Welcome to Spring LIB.
So in this question, we want to derive the equation for the total reflection angle. And we are given the Snell's law that sine theta 2 over sine theta 1 equals V2 over V1. But we can imagine if a wave is traveling from somewhere with a faster velocity, with a slower velocity, to somewhere with a faster velocity. So if we assume this is V1, this is V2, and V1 smaller than V2, then you would expect the angle theta 2 to become larger. But this angle cannot increase infinitely because since theta 2 is larger than theta 1, theta 2 will reach 90 degrees faster than theta 1. So there is a certain angle of theta 1 so that theta 2 becomes 90 degrees. And then if theta 1 is larger than this angle, then no light will be able to enter the second medium. All light will be reflected. So this is called the total reflection angle. So in order to find that, what we need to do is to find this critical value where theta 2 equals 90 degrees. And if theta 2 is 90 degrees, then sine theta 2 becomes 1. Sine theta 1 equals V2 over V1. And from this we can tell theta 1 is arcsine of V1 over V2. Or we can also say that theta of incident angle is arcsine of incident velocity over the refracted velocity. This is part A. Then we also have part B. In this part B, this person is as we can see from the graph, this person is standing 1.8 meters above the ground. And we want this angle to be at least the total reflection angle. So we need to first find the angle. The angle theta is arcsine of velocity in the air over velocity in water. So that is 343 meters per second over 1440 meters per second. That is 13.8 degrees. So after we found that, we can then find the distance x, because x equals the height times tangent theta. So it's 1.8 meters times the tangent of 13.8 degrees, which is 0.44 meter.